Hello. Today we're going to look at section 6.6 proportions from chapter 6 rational expressions and equations. But before we can talk about proportions, we need to talk about a ratio. A ratio is the comparison of two quantities, such as miles per hour or miles per gallon. Ratios are often written as fractions, but they can be written in other ways. So you have the ratio 7:5 or 7:5. And that's written as 7/5. So we can have the word 2, we can have the colon, which is read as the word 2, or we can have the fraction. A proportion is an equation that states two ratios are equal. And when we talk about having ratios in equations, we like to use it as the fraction form. So for instance, 7/5 equals 14/10. Two ratios equal to each other, that's a proportion. There are usually two types of proportions to solve, when the unknown is in the numerator and when the unknown is in the denominator. When the unknown is in the numerator, we can simply use the multiplication principle and multiply both sides by the denominator. So for example, 3/4 equals x over 10. X is on top, we're dividing by 10, so we multiply both sides by 10. So we have 10 times 3/4 equals x over 10 times 10. And that simplifies down to 15/2 equals x. We can also have it where the unknown is in the denominator. And if this is the case, you can flip both fractions and use the multiplication principle. So for example, we have 4/x equals 5/1.2. So we can flip them both, and we get x over 4 equals 1.2 over 5. So you have to be careful and remember that whatever you do to one side of the equation, you have to do the other. So make sure you do flip both of them. Then we can use the multiplication principle and multiply both sides by 4. And we get x equals 4.8 over 5. We don't like fractions and decimals together, so I'm going to simplify it as 0.96. The other way we can do it is we can cross multiply. So again, we'll start off with 4/x equals 5/1.2. And then we make an x and we multiply the two that are combining each line. And we end up with 4 times 1.2 equals 5 times x. So to simplify it, we get 4.8 equals 5x. And then we need to use the multiplication principle again. And we get x equals 4.8 over 5, which again is 0.96. So here's another example. X over 2 equals 7/9. Our unknown is in the numerator, so we simply multiply both sides of our equation by the denominator, 2. And we get x equals 14/9. So another example, 8/x equals 12/5. So for this one, I'm going to flip them both to get x over 8 equals 5/12. And then I'm going to multiply both sides by my 8 and simplify. So again, I multiplied both sides by 8 and then simplified. So for another one, x over 1.3 equals negative 2.4 over 5. Again, the unknown is on top, so I'm just going to multiply both sides by 1.3. And I get negative 3.12 over 5. Simplify it. Again, we don't like fractions and decimals together, so that equals negative 0.624. For another one, we have 16/x equals 12/7. So this time I'm going to cross multiply. So I'm going to multiply the x by the 12 and the 16 by the 7. Simplify it, and then divide by 12 and simplify further. So I divided by 12, and then I could get a factor out of 2 on each side. So I get 56/6. Some friends are taking a trip from Denver to Pueblo. On the map, 0.75 inches is approximately 15 miles. If the distance on the map is 5.5 inches, how far apart are the cities? What we're going to do is we're going to set up a proportion and then solve it. There are a couple different ways you could set up the proportion. I'm going to show you what's probably the easiest. So we start off with the ratio of 0.75 inches to 15 miles. So remember, a ratio is comparing two items. We're comparing the 0.75 inches to 15 miles. And then it's very important to remember the order that you're in. Inches are on top, miles are on the bottom. So we're looking for the miles apart that the cities are. So let's just use m as our variable, so m for miles. Our other ratio will be 5.5 divided by m. So again, we're keeping inches on top, miles on bottom. We set them equal to each other, and then we solve. So our variable is on the bottom, so I'm going to flip them. So 15 over 0.75 equals m over 5.5. Multiply both sides by 5.5, and we get out 110 miles. The Americans with Disabilities Act, the ADA, requires a certain slope, which is the ratio of rise to run, for wheelchair ramps. The ratio 1 to 12 is generally known as the safest. So this means 1 to 12, or 1 over 12, is the rise over run. This is equivalent to saying for every inch of rise, you need 12 inches, which is 1 foot, of run, and the run is the horizontal length of the ramp. If you know one measurement, you can find the other, assuming that the ratio is the required 1 to 12. So for instance, we want the ramp to have 10 inches in rise. How long must it be? So we're looking for the length, or the run. So the equation is as follows. 1 over 12 equals 10 over x. So again, it's rise on top, run on bottom. So 10 on top, x on bottom. So I'm going to flip them both so that my unknown is in my numerator. And then I'm going to multiply by my denominator, 10. So 12 times 10 is 120 inches, which is equivalent to 10 feet. So if I want a ramp that rises 10 inches, I need it to be 10 feet long. We have one more example. So we have room for a 150-inch long ramp. How high will that reach? So again, we set up the proportion. 1 over 12 equals x over 150. So again, the height, or the rise, is the top. The run, or the length, is the bottom. The nice part about this one is that, again, x is on top, so we just multiply by the denominator. So 1/12 times 150, and that's 12.5 inches. Okay, so if you have any questions about this section, feel free to email me, let me know. Come to office hours. So just have a good night.